Yeah, I'm having this talk in English. I hope there's nobody who expected it in German. Yeah. I want to talk a bit about OwnCloud and the encryption module in it, but it's more like I want to talk about crypto design in general, and this is just an example what I'm looking at here. But it's the message is much more general. It's not. I mean, the bug I'm going to show you is not. I think it doesn't have a very high impact, but it tells you a lot about how to design a crypto system. A quick introduction about me. I'm Hanno Böck. I work part-time as a freelance journalist. You may occasionally read my articles on Golem. And I also do fuzzing, which is supported by the Linux Foundation's Core Infrastructure Initiative. And yeah, I had a talk about that earlier today. And occasionally, but this is just like my private interest, I do things with crypto. I hope you all have heard this in one way or another, that if you do crypto, what you should never do is like inventing your own crypto algorithms. Like if you think you invented a super secure cipher that nobody can break, then it's probably not very secure. But I want to ask you a bit, like, how exactly do we interpret that rule? Because I think there are some subtleties that are not entirely clear. And I mean, this is an obvious example. This came up on the IETF crypto working group list, where someone presented a new cipher, the crystalline cipher. And there are a number of things like, yeah, it's designed to be as secure as a one-time pad. That's usually already a sign that something might be strange. Yeah, random sources based upon radioactive decay. Okay, maybe a bit complicated in your smartphone. Hopes to set a new standard in security. And then the key sizes, 16 kilobyte keys, and salt, that's, I think, 128 kilobytes. And you should get them from a truly random source. And you can, if you don't know where to get your randomness, here's the URL where you can download your randomness. So this, I mean, this is obvious. Yeah, that's not a serious project. That's, but you have these people come up every now and then on some crypto mailing list. Someone comes with, oh, I have invented a new cipher. And then like people point out some obvious flaws and then they don't understand it. And yeah, okay, that's not how we do crypto. But that's another thing, and that's like, okay, we all know we should use standard algorithms. We should use algorithms that a lot of people have looked at, like, for example, AES or RSA or SHA-256. But the problem is, even if you use these secure algorithms and put them together into some kind of protocol, that doesn't automatically make a secure protocol. Like, we learned a lot in the past decades about how to put together things and get a bad protocol like SSL version 3. SSL version 3, the building blocks are mostly quite okay. It uses RSA, you can use it with AES or TripleDES. That are all secure algorithms, but the whole protocol together, there are many subtleties, like how do you do padding? What kind of modes are you using from those ciphers? So I would say we need to interpret this rule in a way that you should not build your own crypto algorithms, but you also should not build your own crypto protocols, at least not if you don't know what you're doing. Yeah, and that brings me to OwnCloud. Now, this catched my interest. This was a press release. They later removed it from their webpage, but there was luckily a Reuters news message which reproduced this press release, where they say, okay, they have an encryption module, and this modular approach, you can swap out the existing AES 256 encryption with the new RSA algorithm. RSA is from the 1970s, I think, and AES is from 2001. So Also, I mean, RSA and AES are very different algorithms. RSA is a public key algorithm and AES is a symmetric algorithm. So this doesn't make a lot of sense to swap them out. So, okay, we know OwnCloud has written a press release, obviously by someone who doesn't know a lot about crypto. And that kind of got me interested in looking at what this encryption module actually does. So to understand here is what this module does is maybe not what one would expect. So the thread model is a bit unusual. The idea is you have OwnCloud installed on one server, and you trust that server, but you include some storage space, maybe from some cloud provider or something that you embed, and you don't trust that storage space. For example, if you want to upload very big files, you don't have enough space on your web server, and then you have some external web space that you don't trust. And so you use encryption, and your keys are on the server where your own cloud itself runs, but the files should be safe on some potentially untrusted storage space. So I'd like to say, okay, there are probably not a lot of people who need this scenario, so I assume this is probably not used by a whole lot of people. Or so I think the vulnerability I'm going to show you is not that big of a deal. But yeah, as I said, I want that you learn something about crypto. So. So the first thing I did is just looked how do these encrypted files look like, what's in them, and they start with this text which says something H begins, something about encryption module, and now we have a problem with the screen resolution. The thing on the right is AES, and then 256 CFB. Okay, so we know something about the cipher they are using. They're using AES, and they're using it in CFB mode. So we have to learn a bit about modes. So AES is a block cipher. That means you have a block of, which is for AES 128 bits, and you only encrypt the block. So the algorithm itself, you cannot say, please encrypt this text. You can only encrypt the block. So if you want to use AES in practice, you need some kind of mode to use this block cipher for longer inputs. And there are different kind of modes. ECB, so ECB is basically just encrypt one block by another. And this is not really an encryption mode. This is totally insecure. You should just never use that. It's more or less just an example to explain block modes. Then there are quite common modes are CBC and CTR. They are, for example, used in CBC is still used quite a lot in TLS, although it probably shouldn't be used. And CTR is in more modern products. It's, these modes only encrypt something, but they don't guarantee you that any authenticity. That means if an attacker can manipulate your ciphertext, he may be able to change it in a specific way that, like flipping a bit, or things like that. So you flip a bit in the ciphertext, and the bit gets also flipped in the decrypted text. And then there are modes like GCM or Poly 1305 or OCB. These are so-called authenticated encryption, or more detailed authenticated encryption with additional data. And these modes also guarantee you that unless you have the secret key, you cannot change the content. So if you change something, then the recipient of the message will notice it. The algorithm will just say, okay, here happened an error. This ciphertext is not correct. And then there are some special modes for hard disk encryption, which is a bit messy, but that's not the topic today. And as a rule of thumb, you can say, usually you want to use authenticated encryption. There's almost never a good reason not to use authenticated encryption. So what's this CFB mode? So it's a bit more unusual. It's not a very common mode. The feature of CFB mode is that it's self-correcting, that if you can start the decryption in the middle of a ciphertext, and then you get one bad block and the next block is correct again. So what this enables is that you can do things like seeking. I only want to download the middle of a file or just the second half or things like that. And it's not authenticated. You can flip a bit in the ciphertext, and what happens then is that this bit will be flipped in the decrypted text, and it will change the next block to something basically random. So as an attacker, okay, we cannot decrypt the ciphertext, but we can change the content. And so, okay, how does this matter? Now let's assume someone has an own cloud instance and they are uploading some piece of software for their colleagues, like an installer or just a small exe file. Then can we maybe backdoor that exe file if we're an attacker that can access this space? Now, if we look at an exe file, you will see this program cannot be run in DOS mode. So even on modern systems, every Windows executable still has a DOS program embedded that usually just displays this text. And the interesting thing is that this is always the same, at least if you're using a standard Microsoft compiler. So we have something here. Even if we don't know what this exe file does, we have some bytes here where we know what they are doing, or where we know what they are. So we can manipulate them basically in the way we want. And this is, I created a proof of concept here. So we can just, and another thing is in the fourth line, there's this 000100. This is the offset of the Windows executable header. And so what Windows does is it checks this offset if there's a PE header, which is like the modern exe header. And if it's not there, then it assumes it's a DOS program. So, okay, what we could do here is, and what I did the proof of concept is that if you just, and also for the block length is exactly one line here. It's 128 bits, which is 16 bytes, which is exactly one line here. So if we change anything in the third line, then this will scramble the fourth line. Because we had CFB mode, you change something, next block has random content. So if we change a single bit in the third line, the offset of the Windows PE header will be destroyed, and it will be a DOS program for Windows. And in the fifth line, this stub DOS program is always the same, so we can change that. At least we can change one block of it. Now, that's what I did, and created a proof of concept code. So you're just flipping one bit in the third block, then you're XORing this DOS stub code with the code you want to inject, and then you XOR the ciphertext with it. And then, we have changed the executable to execute some code that we want. Now, I have a demo for this. Here's an OwnCloud instance. And we upload some. I wanted to have a. I had a putty executable prepared here. We'll just download putty then. I'm just using putty because it's a small executable and no, we don't want to start it. Yep. Okay, and now we look on this server storage space. Now we have the directory for the user admin, and we have the putty.exe here. Now the first interesting thing is the file name is still the same, so we're already leaking some information to our attack. Okay. Better? Yeah, and if we look into it, as we saw before, this hbegin and ownCloud encryption module stuff. And now we run this exploit code on putty.exe. Okay, so yeah. And now we download it again. Yeah, save file. And so the putty.exe is the one we had before, and the putty1.exe is the one we just downloaded. And so if we start the original with DOSBox, because it's now a DOS executable, it will say, okay, this cannot be run in DOS mode. And if we start the manipulated one, okay, it prints pun. So that's on the screen, right? Yeah, so what we did was, we had an executable online, and we could inject some code under our control. Now, this is only 16 bytes of code. That doesn't really give us a whole lot, but we will find other places in the executable that usually have zeros or have other stuff that we can predict, and then we can jump around and backdoor many parts of the file. So this is definitely possible to create something exploitable here. Yeah, then I reported this to ownCloud. The first fix they proposed was that they were now using counter mode, and they are always encrypting blocks of 8 kilobytes and then use an HMAC authentication. This is better, but it still has a problem that you can still swap around the blocks inside a file, because every block is encrypted in the same way. And still the problem that the file names are leaked is still there. Then the second fix they deployed is that they embedded a number for the block, so now you can no longer swap blocks around. The file name leak is still there. This is what they shipped in version 9, which was recently released. And now you might ask, is this secure? And I can just say, I don't know. It's secure enough that I did not find anything obvious in it anymore. But I know a bit about crypto, but I'm not like an expert to audit these kinds of things. So in my opinion, this module either should get a professional audit from someone who knows this stuff. And I mean, also there are other potential issues, like how do they generate their keys, and does this all with the key storage make sense? Either this needs a professional audit or the module should be removed. That's what I told the ownCloud developers. Obviously, they decided otherwise. They shipped this now, maybe fixed version. I don't know if it's secure. Yeah. Then you might wonder, why don't they use authenticated encryption? That's also what I asked, like just use GCM. I mean, GCM it's not perfect, but it's definitely better than building your own combination of various modes. The problem with that is that ownCloud is written in PHP, and PHP doesn't support GCM mode. So you currently cannot use authenticated encryption modes from PHP. They plan to change that in PHP 7.1. The problem with that is then you can maybe use it in 15 years, because people tend to use PHP versions which are 10 years old, or I don't know. I think the most common PHP version is still 5.3, which, 5.4 is already out of security support. Yeah. Yeah, maybe. I mean, PHP 7.1 is not released yet, so I think it will be released in summer. Then, okay, you might, how would you do better? What would I propose? And it's a bit difficult because for this scenario, I think there's no ready-made protocol or construction that you can easily use. And I think this is a problem. There should be something like I want to encrypt a file and store it somewhere with a key that is a pretty standard scenario, but there's no really good solution for it. And you solve some problems if you just use authenticated encryption, but then if you want to start, I want to be able to download a part of a file, then you need to chunk that, and this chunking, there's no standard for it. And with authenticated encryption also has some traps where you have to get things right. So I think this is really a lack of some kind of protocol or standard for this use scenario. I thought about one possibility, but I'm not sure if I would recommend it. But I will present it anyway. I thought, okay, we have standards for message encryption, like for emails, like PGP or CMS, which is S-MIME technology. We could say, okay, we use that. I mean, this is with public key cryptography, but we could say, okay, let's use a public key cryptography. It's slower than a symmetric key, but maybe that we don't care. We just want something secure, and this is maybe well audited. But then I looked how would I do cryptographic message syntax in PHP, and in the documentation, this was the example, and it's using RC2 with 40 bits. Yeah, that's kind of export mode crypto history from the 90s. So it's also not straightforward to get this secure. So, and I don't know if this is a good idea for this scenario. So, but yeah. So takeaways: don't invent your own crypto. Don't invent crypto algorithms. Don't invent crypto protocols. Authenticated encryption should be used usually whenever possible, and unless there's a very good reason not to do, that's the way to do it. And I think we lack some proper standards for these kinds of use scenarios, although it's, I think, quite a common thing. There's no standard solution where you can say, here, put in your key, here, put in your thing to encrypt. That's something that should be there and isn't there. And yeah, you probably should not trust the on-cloud encryption module. Yeah, thanks. Other questions?
I'm just asking about your opinion. Do you consider encfs or eCryptFS for this use case as a better alternative?
What was the first one?
It's just one question. Do you consider?
Yeah. I didn't understand the first one. So
no, it was just this question.
Yeah.
So do you consider encfs or eCryptFS as a good alternative for this use case? I
don't know the first one. I know eCryptFS, but the problem is that these disk encryption things, they do a lot of trade-offs between security and practicality, and it's not really nice what they're using either as encryption modes. So it's probably not a good alternative either.
Okay.
And also, I mean, this is probably not available in PHP to include in a web application. And yeah, I mean, you're laughing, but I think, I mean, PHP, whether you like it or not, it's a standard programming language that's used for a lot of applications. And I think there should be encryption technology that's just usable and works. Okay. There's another.
I think the scenario that when you're looking at clouds, having a disk you don't trust is not that exotic. So is there something you would recommend actually if you have rented space somewhere in the cloud and you don't want?
I mean, it depends what you want to do. If I know that there are like backup solutions that encrypt like attic and stuff, but that depends if that matches your use case, because that's not a web application. So yeah, but I don't have a good recommendation. No. Okay. Yeah, thanks.